Hello and welcome back. Today we will continue with Chemistry Chapter 2, Chemical Bonding. In our previous class, we have already learned about chemical bonding, electrovalent or ionic bond, covalent bond, and coordinate or dative bond. So today we will learn about the partial ionic character of covalent bonds. Do covalent bonds show partial ionic character? We know that in covalent bond, electron is shared between two atoms. In a covalent bond between similar atoms, the shared pair of electrons is equally attracted by the two atoms. As a result of this, it is situated exactly in between the two identical nuclei. So in covalent bond as ipiti hamti ale, covalent bond ting chun elements ni atom ni chun ipi bol hamti ale, electron share bol han electron ke kopron hi chun stable hana covalent bond to form in a covalent bond between similar atoms atoms akibang akilo. For example, here we have hydrogen, a hydrogen molecule. So this hydrogen, they share one electron each and they become stable. So in this type of covalent bond, the electrons are situated exactly in the center of from the nucleus. So hydrogen bond hi ipitiam chala chi amani hin attraction han chi hydrogen pan ama attract about to hydrogen pan ama attract about hi ki bang cha thon hi a force lon. The force of attraction is equal. And for chlorine also, since they are similar atoms or the same kinds of atoms, the shared electrons is situated exactly between the two identical nuclei. So the nucleus hanto apana chi electron a share pair hanchu now let us see. However, if the atoms forming bonds are different, the electrons attracting tendency of the atoms may differ. Now, for atoms forming a covalent bond, atoms between two different atoms, atoms in covalent bond form here we have a hydrogen. Hydrogen share one electron, chlorine share one electron. But we know that this hydrogen, it has only one electrons, but chlorine has 7 electrons. That means chlorine has more electrons than hydrogen. So what happens is that this chlorine will attract hydrogen more. The relative tendency of an atom to attract shared electrons to itself when combined in a compound is termed as the electron negativity of the atom. So since this chlorine has more electrons, it will attract the hydrogen more towards it. So this chlorine will become slightly negative. Chlorine hi temkhat negative hi data. So as you pam dal amahin hydrogen hi aha attract so why? Because it has more electrons. Ai lo le tam zo hot zo force of attraction so hydrogen sang hot zo chlorine zo hin hydrogen hi attract ha bol hi. Ja jo chlorine hi temkhat negative data. And hydrogen will be somehow positive. So this type of bond where there is sharing where there is gaining or losing. Chichu bond ham chale electrovalent or ionic bond. In electrovalent or ionic bond, one of the atom is negative and one of the atom is positive. So here in covalent bond also, if the two atoms are different, the force of attraction between them is also different. So here in this case, chlorine will attract hydrogen more. So chlorine becomes slightly negative and hydrogen becomes slightly positive. So this is known as the partial ionic character. Partial or a little bit or half of it. It is partially ionic. We know that ionic is formed between atoms having different charges, that is negative and positive. And this is denoted by delta positive and delta negative. So when we write it like this H-Cl. Covalent molecules which develop a partial ionic are said to be partially polar. Covalent molecules also. Covalent molecules sitting left. For example, here we have hydrogen chloride. Hydrogen chloride is also a covalent molecules. So this type of covalent molecules which develop a partial ionic character. So partially ionic partially polar. Almost all covalent bonds between unlike atoms are partially polar. They are thus polar covalent compounds. Covalent bonds covalent bonds between unlike atoms atoms suppose hydrogen and chloride. Like atoms hydrogen and hydrogen, or fluorine and fluorine, or chlorine and chlorine, or hydrogen molecule, fluorine molecule, chlorine molecule. So achu now we have unlike atoms tiale atom chomchi kyok form han ting tin hi. Suppose for carbon and hydrogen or water. And this type of compound or molecules, they are known as polar covalent compounds because they are partially ionic. Water molecules contain two covalent bonds between the oxygen and hydrogen atoms. These two bonds are not symmetrically arranged, and H2O molecule is V-shaped. This results in the polar character of water. Hence, water is a polar solvent. So here we have water. So water in the chemical bonding between oxygen and hydrogen, we know that oxygen has more electrons than the two hydrogens. So this oxygen will attract the two hydrogens more towards itself. So this oxygen will become slightly negative. And these two hydrogen, since they are attracted towards the oxygen, they become slightly positive. And we know that they are having a partial ionic character. Electrovalent ionic bond tabang bang hi mata samong. Even though they are covalent bond, they show partial ionic character. Ionic bond tabang chu hi wai chu na chu, they are also known as polar solvent. And this H2O or water molecule is V-shaped. See, from this diagram, we can see that a diagram ako na V-shape, V tabang bang ako kigolo hi. Now let us see bonding in metals. We know that metal atoms can easily lose electrons to form positive ions, and they are good conductors of electricity. We know that metal bonding, metal atoms electron are loose in order to be stable. From the previous chapter also, we know that most metals, they lose electrons in order to be stable, and non-metals, they gain electrons in order to be stable. And we also know that metals are good conductors of electricity. This implies that the valence electrons or metal atoms are loosely held by the nucleus and can move freely. From the previous chapter also, we know that the valence electrons of metal elements, they are loosely held by the nucleus. We know that metals easily lose electrons. That means these valence electrons can move around freely. Here in this picture, we have the electron C model of lithium. So what we know is that in this electron C model, we have the nucleus or the proton, that is positive, and the negative, that is the valence electron. So these valence electrons, they can move around freely inside a metal. So this valence electron, because they can move around freely, they also conduct electricity. Now, the simultaneous force of attraction between the positively charged kernels and the mobile electron, which binds the metal's atoms together, is called metallic bond. So we have this nucleus or the positive charge. So, and also we have the valence electron. Hichi positive charge to hin, hichi negative charge valence electron. They can move around freely. There is an attraction between them. The simultaneous force of attraction between them is known as metallic bond. Hichi amo ke ka attraction metallic bond kiti here. Now for your assignment, do covalent bonds between similar atoms show a partial ionic character. 2. What is electronegativity of the atom? Question number 3. HCl or hydrogen chloride is formed by sharing of electrons between hydrogen and the chlorine atom. Of the two nuclei, which atom will exert more attraction? So this question is that in the bonding between hydrogen and chlorine, they share electrons share form hin charge attraction will hydrogen attract more or chlorine attract more? 4. What are polar covalent compounds? 5. Why is water a polar solvent? 6. Define metallic bond. 7. Why is HF polar while H2F2 are not polar? And that will be all for today. And I want all of you to do your assignment. And before you do your assignment, I want all of you to go through your textbook. And if you have any problems and doubts, you can contact me anytime. Thank you.